If r and s are solutions to that quadratic equation, that means that it could be factored as x minus r times x minus s equals 0. Let's expand this. If we expand things out on the left-hand side, this would give us x squared minus sx minus rx plus sr, which equals 0. And if we combine the terms in the middle, this is going to give us x squared minus the quantity r plus s times x. I normally write things in alphabetical order while I can. Plus rs equals 0. But we know that this equation has to be x squared plus 3x plus c equals 0. What that tells us is that c has to equal rs, because these equations are equal. So c equals rs. And also, if we look on the linear terms, that tells us that 3 equals the opposite of r plus s, or if we divide by -1, it tells us that -3 is r plus s. We now have 3 equations in r, s, and c. If we include the given equation, r squared plus s squared equals 33, and this should be enough to be able to solve for r, s, and c, though we only really need to find c. I'm going to rewrite these equations on the right. We've got r squared plus s squared equals 33. We've got r plus s equals -3. And we've got r times s equals c. What I'm going to do is I'm going to take this middle equation and I'm going to square both sides. That's going to be r plus s quantity squared equals 3 squared. And if you multiply that out, you get r squared plus 2rs plus s squared equals 9. But we know that r squared plus s squared is 33 from the other equation. So if we replace that with 33, we have 33 plus 2rs equals 9. We can get rs alone here by subtracting 33 and dividing by 2. If we subtract 33, that gives us 2rs equals -24. And if we divide by 2, that gives us rs equals -12. But we know that rs is equal to c, so when we substitute that in, we get c equals -12, which is answer choice B.